Good afternoon. Now this is last video related with your SFD BMD. We have solved last 5 question papers and around 20 questions we have covered. Now already I mentioned in last video also for mathematics as per our discussion. I have prepared these videos for unit 1, 13 videos around 70 to 80% syllabus covered and unit 2 around 90% syllabus covered. For mechanics of structures, you have to go for mechanics of structure. In this, you have to go for strength of materials. And you have to see the videos for unit number 1. Now we have to draw SFD, BMD. So we have to take moment about, you can take any point. So we will take moment about B0. And then we have VA into 2 to 4 and to 6 minus 1 into 5 minus 20 into 2 into, it will act at center. So we have 1 meter, 2 meter, 3 meter. And then we have minus 4 into 1, which is equal to 0. And from this we will get value of VA, and that is equal to 21.5 kilonewtons. Now apply Fy0. So we have VA minus 1 minus 20 into 2 minus 4 plus VB equal to 0. And therefore we will get VB that is equal to 23.5 kilonewton. So this is 45, 20 into 2, 40, 44 and 145. So 21.5 we have RA 21.5 kilonewton and RB we have 23.5 kilonewtons. Now we will start to draw shear force and bending moment diagram. So we have shear force. We have to first find a left of A, 0. Then we have a right of A, 21.5 kilonewtons. Then we have left of C. So we will plot simultaneously. Then we have left of C, no change, no load. So left of C we have as it is 21.5 kilonewtons. Then we have a right of C. So we have fourth right of C. So we have 21.5 minus 1. So we have 20.5 kilonewtons. Then we have at D, no change, will be as it is 20.5 kilonewtons. So we have same 20.5. Then we have at E, we have 20.5 minus 20 into 2. And then we have, this will be equal to minus 19.5 kilonewtons. Then we have no change of load. So we have 7th. Left of F will be as it is minus 19.5 kilonewtons. Then we have a right of F. Right of F we have minus 19.5 minus 4 is minus 23.5 kilonewtons. And then we have left of B. Left of B we have equal to same, no change, minus 23.5. And then we have right of B. So we have 0. So we will have in this fashion 23.5, then 23.5 and 0. So now shear force 0. So we will consider let this distance will be x. So we have to consider the portion. You can have from left or right, not much change. So 23.5. Then we have 1 kilonewton, no distance is required, only distance of UDL is required. So we have this will be 20 kilonewton per meter, and this distance we have x. And therefore we have SF equal to 0, and that is equal to 23.5 minus 1 minus 20x. And from this we will get 20x equal to 22.5, and we will have value of x that is equal to point of 0 shear force we will have 22.5 divided by 20, 1.125 meters. So we have this distance 1.125 meters. So likewise, we have to find the value of shear force. So now so I got it as, sorry, this is 23.5, no. So we have done one mistake actually. This is 21.5, then this becomes 20.5. So we have value of x. So I have taken reaction actually right side value. So we have this value that is equal to 20.5 divided by 20 is 1.025. So we have 1.025 meters. So we have this value. So this value we have 1.025 meters. So one 1.025 meters. So likewise, we have to draw SFD. Then we will go BMD. So we have this one. So now we have bending moment. So bending moment. Now we will find at A first. At A we have 0. Then we have at C is simply 21.5 into 1. So we have 21.5 kilonewton meter. So we have 21.5 as we have x to the power 0 here. So here also x to the power 0. So where we have x to the power 0, we have BMD x to the power 1. And when x to the power 1, we have x to the power 2 in BMD. Then second at D, so we have 21.5 into 2 minus 1 into 1. And then we have 43 minus 1. So we have this value 42 kilonewton meter. So we have 42 kilonewton meter. Then we have to find at 1.025. So 1.025, where we have SF at 0. And then we have this value that is at SF0. We have M max. And then we have this value 21.5 into, now check distance 1, 2. And then 3.025 minus 1 into 2.025, and then due to UDL we have minus 20 into 1.025, and it will act at center 1.025 by 2. And just calculate this value 21.5 into 3.025. minus 2.025 minus 20 into 1.025 square by 2, and I got this value 52.50 kilonewton meter. Just check 52.51 kilonewton meter. So we have this 52.50. So we have this actually 52.50. Check it. Then we have at E. Now I will come from right. So we have at E is so simple. So we can have 23.5 into 2 minus 4 into 1. So we have 47 minus 4. So we will have this value 43 kilonewton meter. So if we will come from left, it will have more calculations, and then at B we have value 0. So we have this 43. Sorry, we have to find at F. So at F actually we have to first find. So we have at F is simple 23.5 into 1. So 23.5 kilonewton meter. And then at B we have 0. So likewise we have to find BMD. Now from given SFD we have to go for loading. So now we have loading diagram. Loading diagram. So we have first at A, we have final shear force minus initial. And then we have finally 16.43 minus 0. So we have 16.43 kilonewtons plus, so it will act upward. Then we have second W between AC. So we have final shear force minus 3.57, initial minus 16.43 divided by 4, and we will get minus 5 kilonewton per meter. So UDL acting in downward direction. Then we have third at D. So actually this value 13.57 is at D. So we have at D minus 13.57 minus 13.57 minus of minus 3.57, and we have this as 10 kilonewtons. So we have this as 10 kilonewton. And then we have at E we have final shear force 0 minus of minus 13.57, and we have this value 13.57 kilonewtons. So 13.57. Now find point of 0 shear force. So we will say this distance is x. And then we have shear force equal to 0 equal to 16.43 minus 5x. And from this we will get value of x equal to 16.43 upon 5. 16.43 upon 5, and we have this value 3.29 meters, where my shear force is 0. So this is 3.29 meters. A to B. And now we will go for bending moment. So we have this distance 3.29 meters. So we have bending moment. Bending moment. First, we have to find bending moment at A is 0. Then we have second SF0 M max, and that is at 3.29. So 16.43 into 3.29. Now you should be in position to understand this into 3.29 square by 2 means into 3.29 into 3.29 by 2. And we have this value 27 kilonewton meter. If you will not understand any point, you can come and ask in the college. Then we have at C equal to 16.43 into 4 minus 5 into 4 into 4 by 2. And we will have this value equal to 25.72. Actually, we can plot simultaneously is better. So we have 27 power 2, again power 2, 25.72. And now I will come from right. At D, we have simply 13.57 into 1.5. And we have this value 13.57 into 1.5 is 20.36 kilonewton meter. If we will come from right, we have to take all loads. So if I will write here or, then we have this as 16.43 into, so we have distance as 5.5, then minus 5 into 4 into 3.5, and then we will get this answer. Just take 16.43, 5.5 minus 20 into 3.5. Yes, 20.36. So 3736. And then we have at E 0. At E equal to 0. So we have 20.36 and 0. Likewise, we have to solve the problems. So we have solved around 20 problems related with your SFD BMD. So now you should be in position to solve any problem from this. So now we will stop here only.